Hi everybody. Today we are going to discuss about the embedded operating system protocol for synchronization mechanisms. It's another embedded operating systems and modeling techniques. So the synchronization mechanics is very important because both the hardware and the software, the synchronization is very important parameter. It's a key parameter. In that the mutex and semaphores and monitors are the important keys that mutex is mainly used for the to product share resources from the concurrent access of multiple processor and the threads, and only one process or threads can acquire the mutex and the time, preventing other process that the threads from the access in the shared resources until the mutex is released. The semaphores is used to control to share the resources with the limited capacity, and they can use the limited the number of process or threads that can access by the resources, and they use it for the signaling between the processor or threads along with the synchronization and their activities. And the monitors mainly use it to the high-level synchronization mechanism that combines the mixers and the conditions variables, and also that can be provide the multiple process or threads safety access and the shared resources and they communicate with each other. The monitors ensure that only the one process, the thread, can execute the monitoring process time and preventing concurrent access to shared resources mainly. And mutex mainly used to benefit is nothing but to ensure the only one task to or a process can access the shared resources at a time, and preventing a rare condition to the multiple tasks in the or process by the modifying the resources in simultaneously, and provides the mutual executions and ensures the data integrity, and the support resources are the main important key parameter of the mutexes. And Mutexes mainly uses the short or mutual exclusions or synchronization mechanisms used for the embedded systems to protect and to have the shared the resources from the simultaneous access by the multiple tasks and the process. And the Mutex mainly the smart that's compare this always only the one task to a process to access this shared resource on a time, and the first it will check the mutex is available or not. After that it will be available, it will looks the gains on the exclusive the access to resources. After that only it will share, and the process is continue, and it will be transfer and it will be available in the other end. And the semaphores are usage is mainly the synchronization mechanism and shared resources and prevent rare conditions. And semaphores is often used as multitasking systems. These are the important usage of semaphores. And monitors mainly the mechanisms is commonly used in embedded systems to ensure the efficient of the process communication, and the process shared resources avoid the conflicts. These are the main benefits. And mutual exclusion, condition synchronization, and encapsulation, and deadlock. These are the important parameter of the monitor. Deadlock avoidance is the technique to prevent the RAG, that is a resource allocation graph mainly dedicated to graph that represents the allocation of the resources and required for the mail for the process. And the bankers algorithms avoid for the circular weight and the resource preemptions and the timeouts. These are the deadlock available avoidance. Deadlock reductions mainly the resource allocation graph and bankers algorithm, and the wait for graph is the process. Mainly the bankers algorithm is detect the and prevent the deadlock by the simulating the allocating resources, and they represent the waiting relationship between the process and the resources is dedicated to the other parameter. Deadlock recovery mainly the techniques to use the situation, mainly direction the recovery used the algorithms to detect the deadlock recovery by releasing the resource and restarting process. And deadlock avoidance mainly use resources to allocate the strategies to avoid the deadlock situation altogether. And the preventions, deadlock prevention to prevent the implement and the guidelines prevent is allowed to the deadlock from the occurring in the first places. And the key features of the benefits of RTOS mainly the task scheduling and interrupt handling, resource management and interrupt process communication, and deterministic behavior and fault tolerance. These are the six important key parameters available. So the benefits of task scheduling mainly we have the guarantees time execution of the time sensitive task, and the interrupt handling mainly the real time response to the critical events, and the resource management mainly ensures the efficient utilization system and the resources, and the inter process communication enable the collaborate and the coordination between the tasks mainly, and the prescriptive time and control in crucial time is mainly used for economic behavior. These are the important key feature benefit of the RTOS. The task scheduling, which we already seen discussed, and the resource management is a memory process for the memory and the process memory allocation for deallocation of memory blocks for the task and the process. Based upon the task and the process, we allocate the memory units. And allocation techniques is mainly static allocation, dynamic allocation, and memory pools are we arranged for the memory unit. In case of process, we allocate the processor time, and the task and the process we allocate the processor, and the priority based scheduling and the time slicing and round robin scheduling we can use for the processor allocation techniques. So the power management, that's a real-time operating system, the RTOS, and techniques to optimize the power consumption. That's a DVF, dynamic voltage and frequency scaling also is important parameter we can use. And the task scheduling and the sleep models and the power gating and the clock gathering gating. These are all the important parameters to technique and to prevent the power management technologies mainly. Main features, the real-time capabilities and the securities and rich set of the library tools we can use to the main features in the embedded technologies in the future algorithms, and the cost-effective technologies also we can use in the benefits, the cost-effective and the scalability and communication. These are all the important parameter, and community support and interoperability are used in the main benefits of the embedded systems. Thank you.